Salam and welcome everyone. Today we're going to be working on a compression and molar volume of a gas question that says a gas at 250 K and 15 atmosphere has a molar volume 12% smaller than the calculated one from the perfect gas law. Calculate one, the compression factor under these conditions, and two, the molar volume of the gas, which are in the sample the attractive or the repulsive forces. So this question is kind of intertwined. We're supposed to find compression factor, we're supposed to find the molar volume of the gas, and we're supposed to find whether is the attractive forces that are dominating the sample or the repulsive forces that are dominating in the sample. So you have three different questions in one question. So the first thing you have to do is, of course, write down the information that you're given. We know that the temperature is 250 Kelvin. We know that pressure is 15 atmosphere. We know that the molar volume, right, of the molar volume is smaller than that calculated from the perfect gas law. So the molar volume of the real gas is the same thing as 12% less than the perfect gas law. So it's the same thing as saying the molar volume is going to be 88% of the molar volume that you get from the perfect gas law. So we don't know what this is because they're giving us information in percent, and it's also actually what we're supposed to solve. We're supposed to find the molar volume of the real gas, the compression factor, which is Z, and usually the compression factor formula is this one right here, the molar volume of the real gas, okay, divided by the molar volume of the ideal or perfect gas. So that is what the compression factor is. So let's go on to what we know. We know that the perfect gas law is PV equals nRT. We're not given the number of moles because we're told to find the molar volume. So instead, we're going to make this formula into the proper formula whenever you're given a molar volume. So you just divide both sides by n, right? And you cancel out n here. And what you end up with is PVM, which is molar volume, because molar volume is just the volume divided by the number of moles. So I hope this is like you have actually have an understanding, because here we're not looking for number of moles, we're not looking for volume, we're actually looking for molar volume in and of itself. So we have to make sure our formula is in that form. So we have that divided by RT. Well, we've been given our pressure, our temperature, we know the gas constant. So we have the molar volume Vm is the same thing as RT divided by P. So we start to substitute. Gas constant, same thing as 0.08206 dm cubed atmosphere divided by mole Kelvin, that's the unit, times the temperature, which we're given to be 250 Kelvin, and then divided by the pressure, which we know to be 15 atmospheres. Cancel out the atmospheres. Let me use blue. Cancel out the atmosphere, cancel out the Kelvins, which makes sense, right? dm cubed is the unit for volume, mole is the unit of number of mole. So dm cube per mole is molar volumes unit, which is correct. So 0.08206 times 250 is the same thing as 20.515, okay, divided by 15 right here, dm cubed per mole. When you input this information in the calculator to solve for that, you just end up with 1.37 dm cubed per mole. So make sure you have your calculator handy because you need it whenever you're working with questions in thermodynamics or in physical chemistry. So this is it, 1.37. Now we have the ideal gas, or the one we got from the perfect gas law. Now we have to note that we're told that the molar volume of the gas is 12% smaller. So that means we're going to be looking for 12% of something is the same thing. 12% smaller or 12% less of something is the same thing as 88%, right? 88% of that thing. Do you understand what I'm saying? So for example, if we say, let me like explain this using X, okay? If I say something is 12% lesser of X, is this me saying something is 88% of X. Do you get what I'm saying? So this X in this case is not an unknown. This X is what we just solved for, which is the molar volume that we solved of the perfect gas using the perfect gas law. So 12% smaller of this is the same thing as 88% of this. So when we go there, we're just going to have 88% which is the same thing as saying 0.88 of 1.37 dm cubed per mole that we solved, which is for the perfect gas right here, is going to be what is the real gas, right? That we're actually solving for. So you just have to input this information to calculator and solve in 3-sig-figs. When you input that in the calculator, you're going to see that the molar volume of a real gas right here, because this one is for a perfect gas or an ideal gas right here, molar volume of a real gas is the same thing as 0.88 times 1.37, which when you solve it, you end up getting 1.206 dm cubed per mole. And when you do it in what you call it, when you do it in 3-sig-figs, you end up with molar volume of the real gas to be 1.21 dm cubed per mole. So that is it. We've solved the first part of the question. So the second part of the question now asks us to find the compression factor under these conditions. Well, we can see the compression factor is actually the first question, the molar volume is the second question, but we can find you actually end up finding the molar volume in this question before you can find the compression factor, if that makes any sense. Anyways, the compression factor under these conditions, well, we have Vm real divided by Vm ideal. So, your Vm perfect, whatever you want to call it. So we have compression factor Z is the same thing as the molar volume of the real gas, that value divided by the molar volume of the perfect gas or the ideal gas, whatever you want to call it. So you end up with 1.21 dm cubed, okay, divided by mole, divided by the value for the ideal, which is just 1.37 dm cubed per mole. So you cancel out dm cubed, dm cubed, cancel out mole. So you end up with Z equals 1.21 divided by 1.37. You put on your calculator to get 0.883. So I'm going to do this in 2-sig-figs, which is going to be approximately 0.88. You can see that this is the answer to the value of the compression factor. Now, the third part of the question, we want to know whether the sample is the attractive forces dominating or the other one, or is it repulsive forces that are dominating? Well, this is not hard. You just have to remember the concepts, right? Z less than 1 and Z greater than 1. When Z is less than 1, when the compression factor is less than 1, 0.88, like in this case, the attractive forces will dominate, right? They dominate in the sample. But in a situation where the when the compression factor Z is greater than 1, the repulsive forces dominate. So I'm only teaching you guys this. This is not what the question asked me to do. The question is asking me whether attractive forces dominate or not. The attractive forces are actually the ones dominating because the compression factor is 0.88 and the compression factor is less than 1. So since the compression factor is less than 1, the attractive forces will dominate. If you have another question, not this question, another question where the compression factor Z is greater than 1, just know that the repulsive forces are the ones dominating. So hopefully that's very helpful. If you have any questions, please put it in the comment section. If you need extra help with your tutoring this semester and other semesters, make sure you email me at shuhabitutoring@gmail.com. I help students excel in all your courses, regardless of the level of the difficulty. And I teach high school, middle school, and college level students to be the best and to dominate their classes, as well as to excel and enjoy the knowledge of STEM or the field of STEM, whatever you want to call it. I wish you guys all the very best. Stay positive and stay hardworking. Assalamu alaikum wa rahmatullahi wa barakatuh.